So I actually wasn't going to say something wrong about the domain, but I didn't want to have to record the video again. So let me just pick up where I was going. I'm trying to find f composed with g of x. So I write the f function without its x, leave a parentheses where the x was, and inside that parentheses put the right side of the g function. Eventually I want to talk about the domain, and I'm going to need to start talking about it right now. If this function in its unsimplified form, if I put -1 in for x into this function, I would get this disgusting 1 over parentheses 1 over -1 plus 1 minus 6. And this piece right here would be 1 over 0, which would be undefined. So -1 isn't going to be in the domain of my function. So in order to find the domain of my function, it's 2 steps. First, we'll finish this up here in a second, but in fact, let me finish this up and then talk about the 2 steps of finding the domain. This is horrible. So first of all, let me write this way. Make this 1 divided by 1 over x plus 1 minus 6, and the parentheses that I have in the denominator, it's not really necessary anymore, but I'm separating this. Rather than making it a 3-layer fraction, I'm making it a 1-layered fraction. And now I'm going to write this as 1 divided by, going to get rid of this parentheses and make the 6 have a fraction with a 1 in the denominator, because I need to combine these together by getting a common denominator. The common denominator is going to be x plus 1, so that 6 that is in the right numerator, that fraction, to make it combinable with the 1 over x plus 1, I multiply it by x plus 1 over x plus 1. And what I have now is 1 divided by 1 over x plus 1 minus 6 times x plus 1 over x plus 1. So these 2 fractions have the same denominator. I can combine these now, and when I combine them, I get 1 divided by 1 minus 6 times x plus 1 over x plus 1. And I'm going to work on this numerator here. This numerator is really 1 minus 6x minus 6. If I clear the parentheses, I go minus 6 times x and minus 6 times 1. So this is going to be 1 divided by 1 minus, and then 6x minus 6 over x plus 1. I'm going to combine. I'm running out of room here. This is going to be 1 divided by, and then negative 6x, and then the 1 minus 6 is negative 5. So negative 6x minus 5 over x plus 1. If you're dividing by a fraction, you can multiply by the reciprocal. I could factor out a negative from the numerator. I just don't know how ugly I want to get. Let me change this to 1 times, and then invert the fraction, x plus 1 over negative 6x minus 5. And 1 times anything is itself. A okay answer to 8a would be this fraction, x plus 1 over negative 6x minus 5. Might be better if I factor out a negative and say it's x plus 1 over negative 1 times 6x plus 5. There's so much I could do with this. I'm just going to stop at one of these. These would both be acceptable answers for part A. Part B asks me to find the domain of this. And in order to find a domain of a composition, you need to do 2 things. Whichever you have to set, if both pieces are fractions, you have to set the denominator of the right function equal to 0, and the denominator of the answer equal to 0. These are going to be numbers that can't be put in for x. let me just do the algebra real quickly. The right denominator, the right function is the g function. If I set its denominator equal to 0 and subtract 1 from both sides, I'd get x equal to -1. If I plugged -1 in before I started doing any simplifying, I'd get undefined because that fraction would be undefined. After I finish up simplifying, if I put a number in that makes this denominator 0, I'd also get undefined. And let me do the algebra here. Add 5, get -6x equals to 5. Divide by -6, divide by -6, and get x equal to -5/6. So the domain for this, we've only written domains of fractions using intervals. Just to get you experience with other ways to write the domain, I'm going to write my domain in words, just in case when you take a calculus class, if you get a teacher that writes your domains differently. So for B, I'm going to say the domain is all real numbers except x equal to -1 and -5/6. There are ways to write that as a interval. If I want to write it as an interval, I'd put -infinity on a number line, -1 and -5/6 in their proper order on the number line with positive infinity, and then I'd create intervals. The way that we've been writing the domain would be something like this. The domain is -infinity to -1, union -1 to -5/6, union -5/6 to infinity. If you did that just out of instinct, that's completely fine. I'd give you full credit for that, but it's not what was, well, it's not what I show it in the answers, and I just want to be consistent with myself. Let me do the g composed with f of x, but I need another sheet of paper because that problem took all the paper I had, all the room I had. So let's do part C should I say. So for C on number 8, I'm supposed to do g composed with f of x, which means I'm going to write the g function 1 over x plus 1 without its x, leave a parentheses where the x was, and inside that parentheses write the right side of the function that's mentioned second, which is 1 over x minus 6. That's what I'm going to need to simplify. Lots of ways to go about simplifying it. First of all, that parentheses in the denominator can just be dumped. I didn't need a parentheses. The fraction kind of works as a parentheses. To simplify this, I'm going to write this as 1 divided by, put the whole denominator of 1 over x minus 6 plus 1 in a parentheses. And now work on the inside of the parentheses. I'm going to make the 1 into a fraction by writing it as 1 over 1. And I'm going to multiply it by x minus 6 over x minus 6. This is going to give me 1 divided by 1 over x minus 6 plus 1 times x minus 6 over x minus 6. So the fractions here have the same denominator. I can combine them together and get 1 divided by 1 plus 1 times x minus 6 over x minus 6. That numerator comes to be 1, and then plus 1x and minus 6. That numerator is going to be 1x minus 5. So this is going to come out to be 1 divided by the simplifying of the numerator. You get 1x, which is just x. 1 minus 6 is negative 5. Now, it's a division with a fraction. I'm going to change it to a multiplication. When you're dividing with a fraction, you can invert and multiply. And 1 times anything is itself. The answer to part C This is the function that I need. For part D, to find the domain of this function, there's two steps. I set the denominator of the function that's written second equal to 0 and exclude that from the domain. I set the denominator of my answer equal to 0 and set that number equal to 0, exclude that from my domain. So in 8D, I need to set both the denominator of the f function, because it's a function that's written second, equal to 0 and solve for x. I need to take the denominator of my answer, set it equal to 0 and solve for x. My domain is going to be, in words, all real numbers except x equal to 5 and 6. I can do it as an interval, I'll show you in a second, but just because I typed up the domain in words just to get us used to something new, I wanted to show you this. If I wanted to create an interval, I'd make a number line that has negative infinity on the far left edge, positive infinity on the far right edge, 5 and 6 between. I'd make up the intervals, and the intervals would be negative infinity to positive 5, and then union positive 5 to positive 6, and then union 6 to infinity. These are both correct domains. And you should be able to understand that they have the same meaning. They both mean if you plug 5 into this, 6 into this version of the function, which is equal to the original function, you'll get undefined, and 5 into this one, you'll get undefined. I'm going to vote to let us, let's just skip 9 and 10. I don't put these on the test. I don't think they're that important. And in the 18 minutes I have left, I want to do the next concept, which is the big tie between this section and the next section. Specifically, it's finding compositions that are pre-designed to compose to x. So, problem 12, it says find f composed with g of x, show that it just equals to x. Really, I could have just said find f composed with g of x, and then the answer should only be x. This is what I'm doing here. I'm telling you what to find, and I'm telling you what the answer is. Similarly, in part B, I could have said find g composed with f of x, and then the answer should be x. And if it's not x, then I've made a math error somewhere along the way. So let's work on this with problem 12. Problem 12, the f function is 3 minus 4x, the g function is the fraction 3 minus x over 4. Problem 12a wants me to find f composed with g of x, and to find f composed with g of x, I take the f function that's written first, I write it without its x, I leave a parentheses where the x was, and inside the parentheses, I put the g function. Now I need to simplify, and this 4 will cancel with that 4. This is kind of a 4 in the numerator, cancels with a 4 in the denominator. They turn into 1s when they cancel. This actually comes out to be 3 minus 1 times 3 minus x over 1. And both of those 1s can be suppressed. A coefficient of 1 is assumed if it's not written. A fraction over 1 can be rewritten without the fraction notation. So this is just going to be 3 minus x. And now I'm going to clear the parentheses. The minus sign is going to make that 3 flip to negative. It's going to make that x flip to positive. This is going to be 3 minus 3 plus x. The 3's cancel. And I got just x. That's what the answer should be, so I know I didn't make a mistake. Let me try to fit 12b on this sheet. 12b wants me to find g composed with f of x. And if my answer doesn't come out to perfectly x, I have a mistake. How do I find g composed with f of x? I take the g function, which is 3 minus x over 4. I write the g function without the x, because the g function's written first. Whichever function's written first, I write without the x. Leave a parentheses where the x was. And inside the parentheses, I put the right side, in this case, of the function that's written second, which is the f function. So that's going to be 3 minus 4x. So now, in my numerator, I'm going to get rid of the parentheses. As I clear the parentheses, the minus in front of the parentheses will make the 3 negative. It will flip the sign on the negative 4x to positive 4x. The denominator doesn't change as I do that, simplifying the numerator. In the numerator, my 3's will cancel, and I'm going to get 4x over x. The 4's are going to cancel, and I get just x, which is perfect. I found both of these, and both the answers came out x, so I did my answers perfectly. Your 11 should work the same way. And our 13 and 14 should work the same way. It looks like 13 is way harder than 14, so I'm going to do 13 with you rather than doing 14. So 13a would be a great time to pause the video and just see if you can work this without me and then check it. You don't really even need to check it, because if you get x for an answer, you didn't make a mistake. If you get anything other than identically x, you made a mistake. So how do I find f composed with g of x? I take the f function, x minus 5 over 2. I write it without the x. I leave a parentheses where the x was. So the f function had a single x in the numerator. I wrote the f function without the x. I left a parentheses where the x was, and I'm going to put a 2x plus 5 in that parentheses because the g function is the function that was mentioned second. This parentheses I can just drop without changing the 2x nor the 5, because the parentheses doesn't have a minus in front of it, doesn't have a coefficient, it doesn't have an exponent. I can just drop that parentheses. And now, cancel the 5's in the numerator. This leaves me with 2x over 2, and 2x over 2 is just plain ordinary x. I did perfect. I found f composed with g of x, and it just equals to x. That's a good thing. This is going to be an important skill to do these compositions and show that they reduce to x, and we get into the next section. For part B, I'm going to find g composed with f of x, and it should just equal x. To find g composed with f of x, I write the g function without the x. I leave a parentheses where that x was in the g function, because the g function's written first. That's the function I write without the x, and leave a parentheses where the x was. Inside the parentheses, I put the right side of the f function, which is x minus 5 over 2. And now I reduce. The 2 in front of the parentheses will cancel with the 2 in the bottom of the denominator. And this is going to leave me with 1 times x minus 5 over 1 plus 5. I certainly don't need the coefficient of 1, and this doesn't need to be written as a fraction anymore. X minus 5 over 1 is still equal to x minus 5. This parentheses is similar to that parentheses. It can just be dropped without changing the x nor the minus 5. It doesn't have an exponent, doesn't have a coefficient or a negative in front of it, so I can just make this x minus 5 plus 5. Cancel the 5's, and I get just the ordinary, plain ordinary x that I needed to get. If I didn't get ordinary x, then my work wasn't right. So that's kind of everything for part 1. This is going to come back, and lots of new stuff will come back too in section 6.2.